Hey everyone, my name is Luv Aggarwal. I'm a data platform technical specialist for IBM Data and AI, and today I want to have a discussion about bias and discrimination in artificial intelligence and machine learning. And to help me do that, I'd like to welcome Lindy Villapanto and Zach Myrick, both Watson AI technical specialists. Hey guys, how you doing?
Doing well, doing well. How are you?
Good, good. Thank you for joining. So, guys, given recent events around civil rights, discrimination, and equality, the role of AI in society has really come into question. So much so that even IBM took a stand, followed by many other leaders in tech, to ban and suspend our facial recognition programs. The question really is AI helping us progress society, or are there challenges that need to be addressed? And I feel as technologists, as young people, as IBMers, it is our responsibility to discuss these challenges and share our perspective. So I'd just like to start off by thanking you guys for joining me in this discussion.
Thanks.
So, guys, it's clear that more and more aspects of our daily lives are dependent on all different sorts of algorithms, important decisions from who gets a loan to who gets a job. But we want to be careful as we try to build a more equitable world that some of the existing biases we have as humans don't carry over into these algorithms and continue to perpetuate those inequalities. So, Zach, let me ask you, how big of a problem is bias in AI really? What areas of society do you think it impacts, and why is it important that we tackle this problem?
Yeah, well, I think it's very significant, and you've already touched on some key points. But one of the reasons for considering AI for adoption in the first place is, its ability to identify and mitigate human bias. But the flip side to that is, it can bake in its own unconscious bias as you deploy it. So when you take the biased AI systems from the data science labs out into the real world, that's when it becomes a widespread issue. Not just for some of the sort of systemic oppression things that we deal with today, whether it's towards African Americans or other minorities. It affects their livelihood in terms of the decisions that these AI models are making. Whether it's your ability to get approved for a house or a car loan, like you mentioned, or having fair opportunity for an employment opportunity to support your family. When it has bias towards these sort of decisions, that's when it sort of hinders the actual value that it can provide for business and society. And just those distorted results can cause a downtrend of effects. But while AI can be very beneficial to business and society, the only way to really do that is to produce unbiased results.
Right, right. So let's back up for a minute and give some broader context to what AI is or what it isn't in the first place. So, Lindy, let me ask you, what is AI not? Where does AI derive its intelligence from?
Yeah, that's a really good question, Love. And I think it's pretty difficult to understand sometimes because AI is thought of as this very smart, self-learning machine, but it isn't just created knowing everything right off the bat, right? So how it gets its initial intelligence is from humans. So AI is essentially the simulation of human processes by using machines. So, what that really means is that AI is really just a machine extension of humans. So, because many humans already might have some unconscious bias towards a group of people or things, then the AI model purely is just learning that bias from them. And really, it's all about the data sets that you first feed into the model that you're training. So, take a hiring data set, for example. If your initial data set unintentionally has more male hires than females, or more white than non white, then your AI model will learn from that and already have an initial bias for those candidates.
Right, exactly. And that's kind of ironic because a lot of AI systems were developed in order to abstract out the human emotion or bias factor in some of those critical decisions. Yet, here we are facing those very same challenges again. So now that we know what AI is and why tackling that bias is important, let's explore in a little bit more detail some areas where complex algorithms are applied and how they can become problematic. So, Zach, can you give us some examples of where AI is really being used at scale and why those areas are even more important to ensure that we minimize the risk of bias and discrimination.
Yeah, so I can talk about a couple of highly visible use cases, as well as how bias can arise in those use cases as well, and really mitigate the value that it's intended to deliver. So, one for example being the criminal justice system, right? So, AI algorithms in the criminal justice system are used to predict the likelihood of someone who's going to commit a crime in the future, and judges actually use those algorithms to make decisions about criminal sentencing. So imagine if there were bias in the historical data that was used to train that model, then what would happen was it would likely create harsher sentencing for specific genders or specific race and things of that nature. And this would really inhibit or cause a lot of controversy because you would basically give out different sentences for the same crime being committed, essentially. Another example was credit. We talked about this a little bit before, right? But let's say if you're a credit card company and you want to determine a customer's credit worthiness, right? Well, the term credit worthiness, it's a bit, ambiguous or fluid, right? Is that credit worthiness based on, maximizing profit? Is it based on maximizing, the maximum number of loans that can get repaid? If there's bias in that case, then that bias is more so based on various business reasons instead of actually being fair to the customers.
Right. And, that begs the question, how can we incentivize or perhaps enforce businesses to consider equitable outcomes and fairness in their models, either from a consumer behavior perspective or perhaps from a regulatory perspective?
Right. And we talked a little bit about HR and a little bit of systemic oppression in that regard, and we're going to touch on that as well. But one really important use case that I really want to talk about is healthcare. And AI models in healthcare, basically what's happening there is doctors are using those models to determine treatment for patients. So let's say, for example, that you have a healthcare patient who in fact was denied treatment based on an AI model with bias in it. And ultimately, this patient ended up dying. When in fact, this same AI model without any bias whatsoever could have determined that this patient was eligible for the treatment that he needed in order to survive. So in this case, if you don't check for the bias, then the consequence is literally as dramatic as life or death. But if this scenario happens, then what this does is it opens up a conversation about, laws and regulations in terms of, determining who would be responsible for this patient's death. Would it be the doctor who leveraged these biased AI models? Would it be the hospital who employs the doctor? Or, on the flip side to it, would it be the programmer who made the AI model? Or the development company who employs the developer? So those are things you have to consider. But not only there, it gets a little bit further complicated when you have AI models that are considered intellectual property. And if this is the case, then this limits the court's ability to really, question the programmer or even just reverse engineer, what went wrong in the first place. So these are the conversations that need to be had. And if they aren't, then, it leads to a lot of moral, ethical um, consequences as a whole.
Right. So just another thing I want to point out there in that scenario you mentioned about a patient not getting an accurate determination for a potential procedure because they might be coming from an underrepresented group. So there's just not enough valid training data for individuals like themselves, right? There are still techniques that data scientists can use to compensate for some of that, like undersampling or oversampling of data, to introduce a sort of like a negative bias to counteract that data imbalance. So there are techniques, that we can use. So it's easy for us to say, training data has bias, right? But the reality is much more nuanced. Bias can come into play from a variety of different areas. So Lindy, what are some of the ways that bias can show up in our training data?
Yeah, so like I kind of touched on before, really the way an organization collects their data is very, very important. So there are really two main ways that bias can show up in training data, and that's either the data that you collect doesn't represent what's real, or it shows some implicit bias that already exists. So, for example, with the first case, that could happen if a machine learning algorithm is fed for example, more photos of light skinned faces than dark skinned faces. So, because of this, the Face ID system would end up being worse at recognizing darker skinned faces, right? Just purely because they wouldn't be as trained in recognizing them. And then the second case is an example of what happened when Amazon discovered that its internal recruiting tool was dismissing female candidates. So, of course, they had no intention of their tool to discriminate female candidates, but because it was trained on historical hiring decisions that favored men over women, it ended up learning to do the same without realizing that bias. And then it's also possible to show bias during the data preparation stage as well. And this more involves picking and choosing which attributes that you want the algorithm to consider, right? So let's just take the example of the recruiting tool again. So an attribute could be the candidate's gender, their education level, or their years of experience. And this is pretty important and is often what people call the art of deep learning, because you really have to be careful in choosing which attributes to consider or ignore, because that can just significantly influence your model's prediction accuracy. But on that note, while the attributes impact on accuracy is really easy to measure, its impact on the model's bias isn't.
Right, exactly. And you mentioned a lack of diversity in, let's say, facial recognition data sets. Um, that's a real problem because some of the most popular gold standard training sets that we have for facial recognition are something like 70% male and 80% white. So they really are not a representation of what reality looks like. And as you mentioned about the recruiting tool, even not considering gender as an attribute, there can be other attributes that can tend to um, predict what gender could be and then continue to discriminate on those attributes. So, we might get into this risky slope of actually amplifying injustice and inequity. So, Zach and Lindy, why is mitigating bias in AI so hard to address?
I'll touch on a couple of reasons, and then I'll pass it back on to Lindy. But one of the reasons why is because the introduction of bias itself, when creating an AI model, is not always transparent or upfront to see, right? And on top of that, once by the time you do realize that there is bias in your AI model, you have to identify where it's coming from, and then not only that, but you also have to figure out how to get rid of it. The other thing to consider too is that deep learning, which is a technique in AI, the way it's designed, it's not designed with bias detection in mind. So when you're testing deep models for performance, the way that process works is you have a developer and they have a data set, and you split the data in two sets, right? You have one set that you train the AI model with, and then you have one that you use to evaluate the performance of the model to verify that it outputs the results that you want. But the thing about this is that the data that you use to test the performance of your model has the same bias as the ones that you use to train it. So there's no way to even test that there's bias in the data sets at all.
Right. And then the other challenges include the lack of social context, and then really what the definition of fairness really is. So, in regards to the lack of social context, basically the root of the problem is that the way that computer scientists are taught to frame problems aren't always aligned with the best way to think about social problems. So, within computer science, it's considered good practice to design a system that can be used for different tasks in different contexts. So, you're able to save a lot of time coding a whole new model that could take weeks or months, and you're able to do one for every instance. But what that does is ignore a lot of social context, right? So what that means is you can't really have a system designed in Illinois but then be applied in California, because different communities have different versions of fairness. Or can't have a system that you apply for fair credit worthiness results to then be applied to employment. Just really how we think about fairness in those different contexts is just totally different. And then that kind of just ties into what the definition of fairness is as well. So, in our society as a whole, I don't think there is a clear cut vision of what the absence of bias should look like, right? But what makes it harder is that in computer science, the concept of fairness has to be defined in mathematical terms. So there has been a lot of research done with the concept of bias within computer science, and they found that there are many different mathematical definitions of fairness that are also mutually exclusive. So let's take the hiring example again for instance. So does fairness mean that the same proportion of white and non-white applicants get hired, or should they take out race altogether and just go based on skill and level? It's not really possible to fulfill both definitions at the same time. So at some point, you just have to pick one, which then just again fuels the problem of what the definition of fairness really is to different people.
Right. So fairness can become, very difficult to define. An interesting way to protect fairness is can be by using the idea of protected classes to ensure that our models are adhering to strict definitions of certain attributes. Like for example, with gender, we can enforce that 50% of our outcomes are males and 50% of our outcomes are females. This can really help mitigate some of the bias even with a lot of flawed training data. Now, this kind of technique clearly doesn't work for all attributes, but for certain attributes like gender, it can help mitigate some of the issues. All right, guys, thank you for your insights. I want to change gears a little bit. I want to know what specifically is IBM's approach? What are we doing different to help mitigate some of these challenges that we've discussed so far? Zach, maybe from a tools and platforms perspective, what is IBM doing?
Sure. So one of the things that you touched on earlier was that we shut down our facial recognition business simply due to the fact that we don't want ourselves, our vendors, our customers, or anybody else using the product to use it for discrimination purposes. And the other thing that we're doing also is that from an AI lifecycle perspective, right? You have the training data, you have the AI creation, and then you have the evaluation once the model is deployed. So for the first two phases, we have a toolkit called AI Fairness 360. And what this allows you to do is it allows you to detect or detect bias and correct it as you're creating the AI models. So whether if it's in the training data, you may not know if there's any bias in that whatsoever. That's where AI Fairness will come in. And then throughout the creation process, this tool has several different algorithms used to identify bias and correct it at the source. And then once it's deployed, we have Watson OpenScale, which is a part of our AI portfolio. But this allows you to monitor and detect the performance and evaluation of your AI models. And it can also detect bias and correct it without you having to recreate the model itself. So the combination of AI Fairness 360 and Watson OpenScale, it allows you to identify and mitigate bias throughout the entire AI lifecycle.
Right. So it sounds like AI Fairness 360 helps us mitigate bias when we're developing our models, and Watson OpenScale can help us monitor bias after we've deployed them into production.
Yep.
And Watson OpenScale can also help us protect against model drift, right?
Yes, it does. So without you having to manually, put data into the dashboard to make sure that, the performance of your AI models will still be the same, we have drift protection that supports that.
So, Lindy, what about from a corporate citizen perspective? What is IBM doing to help on that front?
Yeah, great question, Love. So, IBM is actually taking action on a few fronts. So, as we already mentioned, we suspended our facial recognition programs because we didn't feel like it was being used to progress equity in criminal justice use cases. And in addition to that, we also have developed a number of initiatives around equal access, like our Equal Access Developer Toolkit, to build more accessible applications. And then finally, our leadership, including our CEO, Arvind Krishna, has pressured Congress to pass fundamental racism reforms, including more accountability for misconduct, responsible technology policies that really test for bias and is also audited and reported for increased transparency. And then also expanded opportunity for training and education for all Americans, regardless of race, with Pell Grants and P-TECH.
Great. Well, Zach, Lindy, you guys brought up some really important and critical points, and it's now clear to me and hopefully those watching how important it is that we question the outcomes of AI models that have become such a critical part of our lives, and that we ask, is this outcome fair? Is it unbiased? Is it equitable? And I'm optimistic that this is a challenge that will be solved. So just within IBM, we have a massive research arm working on solutions to bias creep every day. And just like anything, this is an ongoing process, just like discrimination in any other aspect of society. So with that, I would like to really thank you both, Zach and Lindy, for joining me today to discuss this topic. And thank you to everyone watching. I hope you were able to learn something from our discussion.